All right, this is the practice for 12.1. The first one says a 2 kilogram chunk of aluminum starts at 10 degrees Celsius. How much energy does it need to reach 23 degrees Celsius? Which equation am I going to use? Total energy, change in energy, or the equilibrium stuff? How many objects are involved? Just one, aluminum. That's it. So it can't be the equilibrium one. So it either has to be the total or the change in energy. How many temperatures do we have? 2 different temperatures. So it's got to be asking about the change in temperature. So it's going to be the change in energy. How much energy we need to add to it. So we have 2 kilograms, 10 degrees Celsius, 23 degrees Celsius, and 897 joules, kilograms, Kelvin. What's the 2 kilograms? Mass. What's the 10 degrees Celsius? 23 degrees Celsius. Temperature, and it's our second temperature, so which one's initial? 10 is initial. That makes this one final. What's the 897?
Temperature.
Nope.
Q.
Nope. C. There we go. C. What are we looking for?
Energy.
Energy, which for energy is Q. Now it's how much energy we're adding, so it's actually delta Q, which makes it this equation right here. Delta Q equals N cat. N cat. Because it's a cat. Okay, let's plug in our equation here. We have, we're looking for delta Q, 2 kilograms times 897, 23 minus 10. Plug it in, what do you get? I'm recording, guys. Hush. All right, so we should have 23322 joules. So a lot of energy. A lot of energy. Now, for the next one, you are welcome to use the big long equation or the grid. Either way is fine with me. It says a 2 kilogram chunk of aluminum at 10 degrees Celsius is dropped in 5 liters of water at 23 degrees Celsius. What's the final temperature? And it gives you the specific heat of water, and we have the specific heat of aluminum up there. How many different objects do we have in this? 2, aluminum and water. So it's an equilibrium problem. So that means we can use this. You know, a lot of people get confused because there's so many M's and so many C's and so many T's. So that's why I did the grid. And you have your objects. And then you have M, C, T, Q across the top here. Initial, initial, final, final. What are our 2 objects? Aluminum.
And water.
Aluminum and water. What's the mass of the aluminum?
2 kilograms.
2 kilograms. So make sure you put it in both initial and final. What's the mass of the water? 5 kilograms. Good. 5 liters, 5 kilograms for water. What's the specific heat of aluminum? $897. It's up at the last problem. And what's the specific heat of water? 4180. What's the initial temperature of the aluminum? 10 degrees. Now with this one, you can either do Celsius or Kelvin because it's doing a change in temperature. So I'm going to leave it in Celsius, just less calculation, that's okay. If you feel like you're not really sure when to use Celsius or Kelvin, just use Kelvin. Okay, what's the initial temperature of the water? 23 degrees. And what's the final temperature of the aluminum? We don't know. What's the final temperature of the water?
The same thing.
The same thing, but we don't know. Because after they sit in together, they're going to have the same final temperature. We just don't know what that is. That's what we're looking for. So we're going to use the grid. This times this equals Q all the way across for each single one. So we have 2 times 897 times 10, 17940. Then 5 times 4180 times 23, 480700. Then we get to these ones with the letters in them. That's okay. Just include the letter TF. Same thing for this one. 920900 TF. Then we're going to go down the side here. Initial equals final. And rewrite it down here. Now, I know it's hard to see on the board, so I'm going to write it off to the side here. I just need to make some room with my eraser. There we go. So I'm just going to rewrite this column so I can solve it algebraically. It's easier when it's across. And that is supposed to be a plus, not an equal sign. There you go. Okay, add the stuff up on the left. And the stuff on the right. And then divide. And I get about 22 degrees Celsius for our temperature here. And that's our practice. Questions on this? I think you've done it in chemistry, so it shouldn't be too bad.